No other star's death is as eagerly awaited as that of Betelgeuse. After all, the red supergiant will treat us to a spectacle during its explosive finale that will probably shine brighter than the full moon and be visible even during the day. In fact, not so long ago, astronomers even suspected that the supernova of this stellar colossus was imminent, and now the shoulder star of Orion is making headlines again. On the one hand, there is the assumption that Betelgeuse is rotating significantly faster than it should because it once swallowed another star. And on the other hand, there is the assumption that it has an unknown companion called Beetle Buddy. So stay tuned to find out what is currently happening with Betelgeuse and how it is keeping the research world in suspense. Bigger, the mighty sun. In our broad perception, our mother star often embodies a cosmic measure of all things. And that's not particularly surprising because, after all, our source of warmth and life has an incredible diameter of almost 1.4 million kilometers, theoretically enough space for 1.3 million Earths. And yet, as soon as we start comparing the sun to other giants of the universe, even our mighty central star begins to fade more and more. In the constellation Orion, about 650 light-years away from us, Betelgeuse surpasses the sun in every conceivable way. The red supergiant has a diameter 800 times that of our host star, and as a result, it shines a whopping 10,000 times brighter. Well, that is if it sticks to the usual pattern, of course. A few years ago, Betelgeuse astonished experts by dramatically losing brightness within a few weeks. Periodic fluctuations in brightness are not unusual for Orion's shoulder star, but this time it dimmed much faster and more intensely than normal. A brief explanation for better understanding. The astronomical unit of magnitude indicates the apparent brightness of celestial body, and the smaller the magnitude value, the brighter the object appears to us. And while Betelgeuse, with an average luminosity of 0.3 to 0.4 magnitudes, is actually the 6th to 7th brightest star in the entire sky, it dimmed to 1.289 magnitudes in December 2019 and consequently plummeted to 21st place in the brightness table. This was a conspicuous development, to say the least, which immediately led some researchers to the spectacular assumption that Betelgeuse's supernova could be imminent. It is clear that this will happen sooner or later. After all, as a red supergiant, it is now in the very last chapter of its stellar life. And as befits a giant of this magnitude, Betelgeuse will not quietly and secretly bow out of the cosmic stage, but will undergo a brutal explosion that will increase its regular luminosity by a factor of 16,000. Astronomers estimate that it will then reach an apparent brightness of minus 9.5 to minus 10.5 magnitudes. As a result, it will shine as brightly as a full moon and can even be easily seen during the day. The crucial question now is when exactly Betelgeuse will explode. And the honest answer is that we simply do not know. It is clear that this had not yet happened in 2019. Ultimately, the supposed supernova precursor turned out to be nothing more than the result of a massive plasma eruption. This created a dust cloud that was no less powerful, obscuring almost a third of the star from our view on Earth. In theory, however, it is indeed possible that Betelgeuse will make an explosive exit today or tomorrow, provided it's already in the silicon burning phase, which typically lasts only a few weeks. However, most models indicate that Betelgeuse will not explode within the next 100,000 years, but at the latest in a few 100,000 years. Has Betelgeuse swallowed another star? And so we still have some time left to unravel the mysteries of the red supergiant, one of which concerns its rotation. Images from the ALMA radio telescopes in Chile suggest that it's rotating at a speed that is insane for a star of this spectral class. More precisely, its rotation speed is more than 5 kilometers per second, which is 50 times higher than would be expected for a red supergiant. And that contradicts the usual pattern. Aging stars actually tend to slow down as they expand. Jing Ma from the Max Planck Institute for Astrophysics in Garching, Bavaria, states that Betelgeuse is even the only known red supergiant for which such rapid rotation is assumed. In detail, the corresponding speed is attributed to the bipolar structure of the surface. While one half shows a blue shift, the other shows a red shift of several kilometers per second. Okay, but what is responsible for this high stellar rotation speed? Scientists are discussing several possibilities. The first and probably most exciting is based on the assumption that Betelgeuse once absorbed one of its counterparts. In other words, when it swelled into a supergiant around 100,000 years ago, it may have swallowed a companion about the size of the Sun. In this scenario, the large increase in mass caused the swallowed star to transfer the angular momentum of its orbit to the outer shell of Betelgeuse, thereby accelerating its rotation. This assumption has not only been tested in a computer model, but also corroborated by real observations. Images from the Herschel Space Telescope had already shown in the past that areas of ejected stellar material exist on one side of Betelgeuse. These shell-shaped envelopes were generally associated with the impending supernova. But coincidentally, they are also located at almost exactly the distance one would expect after an incident of stellar cannibalism. The gigantic bubbles of ascending and descending plasma that adorn the surface of the star lead us to the second explanation. The rapid movement of these plasma bubbles can also produce the observed red and blue shifts in radio emissions. Conversely, it's therefore conceivable that Betelgeuse is not actually rotating too fast, but is instead leading astronomers astray with a kind of optical illusion. If a very large convection bubble or a group of convection bubbles moves toward the observer and another moves away from them at the same time, even a star that is not rotating at all can appear to be spinning around at breakneck speed. And indeed, a recent reanalysis of the ALMA data in combination with an astrophysical model has shown that this is actually the more likely scenario. According to the researchers, the probability that the maps generated in the simulation were incorrectly interpreted as high rotation rates is 90%. This is again due to the low resolution of the ALMA images, which may have distorted the true movement of the star's surface. But even if Betelgeuse never swallowed another star, that doesn't mean it never had stellar company or still does. There are still exciting clues that the red supergiant is accompanied by an undiscovered companion. The search for Betelgeuse. Does Betelgeuse have a companion star? Basically, Betelgeuse's brightness and surface pulsate at a rate of around 400 days. However, the celestial body also exhibits a secondary, significantly longer brightness fluctuation that follows a cycle of 2,170 days or just under 6 years. The question of what causes these long-period fluctuations remained an unsolved mystery for a long time. To finally shed some light on this stellar mystery, a team from the Flatiron Institute in New York set out to carefully re-examine all observational data on Betelgeuse. And it paid off. The reanalysis revealed some surprising anomalies, starting with the fact that the 6-year cycle in the star's light curve is subject to a different rhythm than the subtle 400-day pulsations. In detail, the long-period fluctuations are shifted against the rhythmic pulsations. And yet the scientists were unable to uncover any accompanying phenomena that would be associated with causes such as rotation sequences, magnetic field effects, or convection currents. And so it came to pass that in the end, there was only one explanation that left no fundamental questions unanswered, namely, that Betelgeuse is accompanied by a smaller star. Since Betelgeuse is called Betelgeuse in English, it was given the name Betelgeuse. But what actually supports its existence? Well, first and foremost, the fact that the strange 6-year fluctuations would coincide perfectly with its orbit. In other words, as soon as Betelgeuse disappears behind Betelgeuse, as seen from our perspective, the secondary period reaches its lowest point of brightness. However, as soon as a companion appears next to its more impressive partner, the luminosities of the two stars combine, and the brightness reaches its maximum. At the same time, the companion star could also take on the role of an in-house dust pusher, influencing the distribution of dust clouds, and thus playing an additional role in Betelgeuse's brightness changes. And there's no denying that it all sounds pretty plausible. But how come we haven't discovered Betelgeuse long ago? Well, that's probably due to its low mass. According to calculations, it is likely to weigh just around 1.7 solar masses, while Betelgeuse itself is almost 20 solar masses. Furthermore, Betelgeuse is also likely to pass quite close to the red supergiant, more precisely at a distance corresponding to only 2.4 Betelgeuse radii. Against this backdrop, the companion is clearly outshone by its colossal partner, and the brightness fluctuations and pulsation of Betelgeuse do the rest to blur the traces of Betelgeuse in the light curve. However, the search is not entirely hopeless. With the help of large telescopes, it may be possible to find further evidence of Betelgeuse's existence and perhaps even reveal what kind of star the dying supergiant is accompanied by. And now we'll show you how to make sure you never miss another video from us. Just click on the thumbnail and subscribe to stay up to date. We'll see you soon.